Hello, eighth graders. In this video, I'm going to demonstrate how to do the natural selection of antibiotic resistance. So in this activity, we simulated the resistance of different bacteria to antibiotic and what's gonna happen if we consistently take our antibiotic and finish our medications, or if we skip uh, out taking antibiotics, or already stop taking the antibiotics, even if we haven't finished the whole cycle. So I'm going to read this paragraph first. Investigation: have you ever taken antibiotics? Did you follow the directions completely? All antibiotics need to be taken as directed, which usually means taking all the pills and not stopping even if you begin feeling better. Why? Millions of harmless bacteria naturally live on and inside of your body. When harmful bacteria appear on the scene, your body's immune system can usually keep a small population of them under control. If, however, these bacteria reproduce too quickly, you suffer consequences, and this is called an infection. Antibiotics help your body fight off an infection by killing these harmful bacteria. Unfortunately, a small number of bacteria in any population may not be affected by the antibiotic as quickly. This bacteria, which is considered more resistant to the treatment, continue to reproduce and grow. Completing the full course of antibiotic as prescribed helps make use that these bacteria do not survive and therefore won't make you ill or infect anyone else. So your challenge is, why is it important to take an antibiotic as prescribed? Meaning you will consistently take it and finish the whole cycle and not skip any day, or uh, already stop taking it just because you already feel better, and not complete the cycle. So what you're going to be needing are the following. So you're going to need 50 discs. There should be, in those 50 discs, there should be 20 blue, 15 yellow, and red, 15 red. And then you're also gonna need this number cube and the copy of the bacteria graph, which is already included in this document. So first, imagine that you are sick with a bacterial infection, and your doctor prescribed an antibiotic to be taken every day for 8 days. So that's the full cycle. Color this represent the harmful bacteria that are in your body. The least resistant bacteria is the blue disc. So this represents the least resistant. So when you say least resistant, it means that uh, it is the one being killed first by the antibiotic. And then resistant bacteria, medium resistant, are the yellow ones. So when all of the blue are killed, the next one to be killed by the antibiotic is the yellow ones. And the extremely resistant bacteria are the red discs. So this is the last bacteria to be affected. So each time you toss the number cube, it is time to take the antibiotic. The number on the number cube tells you what to do. All right, so this is the procedure. In this activity, you have a pile of bacteria, but at the beginning, you will work with your partner to collect data. Begin with 20 discs only. So those 20 discs, you have 13 bacteria, 13 blue bacteria, 2, 4, 6, 8, 10, 12, 13. 6 yellow, 2, 4, 6. And then one red, one least or most resistance rather. These discs represent the harmful bacteria living in your body before you begin to take the antibiotic. Set the extra disc aside for the meantime. So this is not included yet. We're gonna focus on this. Okay, and It is time to take your antibiotic, toss a number cube, and follow the directions on in the number cube below. So if you pick 1, 3, 5, and 6, you will take the antibiotic on time so bacteria can be killed, and you will remove 5 discs. We're gonna start with blue because this is the least resistance, and then when we run out of blue, then we're gonna take from yellow, and then when we run out of yellow, we're gonna take the red. And then if you pick 2 and 4, that means you forgot to take antibiotic, then we're not gonna kill anything from these bacteria. And number 3, record the number of each type of bacteria in the in your body after each turn. And then the bacteria are reproducing. So before you proceed to the next turn, it's reproducing all the time. If there is at least one bacteria present for each color, we're gonna add uh, one more disc from our pile right here. All right. So for example, if you have resistant yellow and extremely resistant red bacteria in your body, this is your body, then you will add one yellow and one red. But if you run out of blue, for example, you're not going to add anymore because nothing will reproduce anymore. And then we'll keep repeating step 2 to 4 until you have completed this table right here. Okay? So you will use this data later on to graph the population for each of the bacteria and uh, eh, for the total number of bacteria on the bacteria graph. I will show you that later. Provide a separate page. Use different colored lines or lines with different patterns to represent each type of bacteria and fill in the key accordingly. All right. So I'm going to start editing this with Cami so we can record. Okay. So again, just a reminder, all the rest, you will take the antibiotic. If it's just 2 and 4, you will not take the antibiotic, meaning we're not going to kill off any bacteria. Okay? So let me show you again. This is your pile. This is the bacteria in your body. Let's start at the beginning. We have 13, 6, and 1. And then let's see. First is 5, meaning you're gonna kill off some bacteria. We'll start with blue because this is the least resistant. So 1, 2, 3, 4, 5. Okay. Now we have 3, 4, 5, 6, 7, 8 remaining. So we have 8 remaining. For this is still 6. Still 6. For this one, it's still 1. And then the total would be 15. Okay. All right. Now, since it's reproducing, we're going to add 1, then add 1, then add 1. All right. And then, okay, this time, we did not take the medication, which means we're not going to kill off anything. So our remaining is already 9 for the blue because it reproduced, and then 7 for yellow and 2 for red. And the total for that is 16, 17, 18. Right? Okay, let's see. Let's roll the dice again. And once again, we did not take the medication. So, okay, hang on. We skip adding we have to add first. Sorry. We're going to have to roll it again. All right. So they have to multiply first before we roll. Okay, now it's 2. And just like 4, we are not taking any medication in here. So we're not taking anything from this. We now have 5, 10. So if you will notice, they keep on increasing if we're not taking medication. This one is 8. This one is 3. And the total is 20, 21. So it's now higher than the original. Hopefully, we take medication this time. All right, we have now 3. So we're going to kill a 5. 1, 2, 3, 4, 5. Now we have 5 remaining for blue. And this one is 5, 8. And then this one is 3. All right. So since they're still blue, it's going to reproduce again. It's going to reproduce. It's going to reproduce. All right. And then we'll roll the dice. It's 3 again. So we're taking medication. We're going to kill a 5. 1, 2, 3, 4, 5. So there's now 1 remaining. Sorry, I forgot the total of this. 13, 16. So there's just 1 remaining. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. And this one is 4. So a total of 14. Okay. And then since there is at least 1, we're going to add 1 more. 1 more and then 1 more. Then let's see. Hopefully we take antibiotic so we can get rid of the blue. Okay, 5. We take antibiotics. So 1, 2, 3, 4, 5. So we're not taking from the yellow since we ran out of blue. Okay. So there is now 0 blue finally. We got rid of it. And 7 yellow and 5 red. All right, so we now have 12 remaining. All right, so since there's no blue anymore, it's not gonna reproduce finally, but there's still yellow and there's still red. So they're gonna keep on reproducing. Okay, we're gonna roll again. Okay, it's 5. We're taking medications. So we're taking from this because this is the next less resistant. 1, 2, 3, 4, 5. So we now have 0 blue, 3 yellow, and 6 red. So the total we have is 9. Okay. Next one. This is the last day we're taking medication. Okay, but before that, they will reproduce again. Okay. Okay, it's 2. Unfortunately, we're not taking any medication. So even though there is no blue, there's still 4 yellow. And there is now 7 red. So we were not able to kill out the red and yellow, unfortunately. So from 9, it increased to 11, right? Because on the last day, we did not take the medication. Okay, so it's not included in the data anymore, but let's see if we are able to eliminate. Sorry about that. So it's 6. So if it's 6, uh, hang on, it's gonna reproduce first. So if it's 6, we're gonna eliminate the yellow already. So 1, 2, 3, 4, 5. Okay. So there will be no yellow remaining anymore, but there are still red. Okay. So you just have to keep on taking medication. If you don't, then you're not killing any bacteria. You're gonna add one more, and it's gonna take more time for you to medicate. So it's 3, so we're taking 5. But then there's still bacteria, so we're gonna add one more. And hopefully on this last, it's 6, so we're taking medications. That's the only time we could eliminate all of it. So I think that that would need us 2 more rounds, or 2 toss, in order to eliminate it fully. Okay, so we're now gonna go to graphing. All right, so graphing is on the last page. Okay, so before you proceed to graphing, make sure that you answer this question, but we're gonna skip it for the meantime. All right, so how will you do the graphing? All right, in order to do the graphing, I suggest that you write it, or you write the data first on a piece of paper, so you don't have to go back and forth from the previous page to the next. If you are using a paper copy, you can detach the graphing page from the last portion of your worksheet. Anyway, it has a portion that you can write your name on it, so your paper is not going to be lost, so that you can look at your table and the graph at the same time. Okay, so since I'm going to do the graphing on online, then I'm going to have this paper to base it on. Okay, all right, so we're gonna graph it one at a time. Okay, so the first thing I'm gonna graph is the blue bacteria. So that will need me to use blue ink. So I'm gonna use blue in here. All right, it doesn't have to be blue. It's just that you need to uh, signify first that you're using blue marker in here. Let's just use drawing. Okay, I think this is better. All right, so that's the blue one. So at the beginning, there are 13. So this is the beginning. So this is 10, 11, 12, and 13. So that's the first day on the initial, rather. On the first day of taking medication, it went down to 8. So from 10, 9, 8. And then third is it went up to 9. Second day, and third day it went up to 10, and then went back to 5 because we took medication most probably, and then went down to 1, and then the rest of the day there's no blue bacteria anymore. And then the next thing that you're gonna do is connect them with line. So let's see if there's a line in here. Okay, connect. So that's what you're gonna be doing if you are using uh the Kami. All right. Okay, and then let's grab the yellow. So we're gonna use yellow, of course, but again, it could be different color. If you have a different color of coloring pencil, just mark it in here so I know that you're graphing yellow for the resistant bacteria. Okay, so at the beginning there are six, and then when we started taking, there's still six, and then we did not take medication, it kept growing. Oh, sorry. Went to seven, and then eight on the third day, and then it did not grow anymore, or some of it are taken because we took medication, and then grow again, and then went down, and then three, and then grow again because we did not take medication again. So that's the trend. We'll just connect them with line. So that is our resistant bacteria. Next one would be the most resistant. So that's red. It started as one, and then one at the first day, and then two, up to two, and then three, and then three, and then four, and then five. So look at what's happening to the most resistant if you stop taking medication, right? And then connect them. All right. And finally, the total. So for the total, we're just going to use this color. It started as 20 and then went to down to 15 and then 18, 16, 17, 18 because we did not take medication, and then 21, and then we took medication, so it went down to 16, and then another medication went down to 14. So see the trend if we keep on taking medication. 14. But then we forgot again. So 14, and then 12, and then 9. But then we forgot again, so it went up to 11. So that's the trend. Then just connect them. So this is already 4 points. 1 point for each graph. Okay. So that is our graph. Sorry, I forgot to mark the resistant and the total. Okay. So that's your key. All right. Now, in answering the questions, uh, did the antibiotic help you to completely kill all the harmful bacteria living in your body? So explain based on your result. So based on our result, it did not fully kill it because some still remain. And then number two, imagine infecting someone else immediately after catching the infection before you started taking the antibiotic. With what type of bacteria would you be most likely to infect them? So just compare it with the numbers. Okay, so based on the number, which most likely would you spread out? B, imagine infecting someone else near the end of the antibiotic course. Okay, meaning you're on this part already, on the latter part. Okay, with what type of bacteria would you most likely infect them? So, which is increasing in number on the latter part. Okay, see this? And then letter C, suppose that most infected people stop taking the antibiotic when they begun to feel better. For example, consider the point in the situation when there were only these three harmful bacteria left. What do you predict might happen to the antibiotic's ability to kill the harmful bacteria if the infection returns? Explain your reasoning. So if there's only this bacteria left, of course, they will mutate. They could just still change. If you take the same antibiotic to treat this, would it still work? Why or why not? And then three, use your graph to describe how the population of each type of bacteria change over the course of antibiotic treatment. So describe this graph right here. And then why is it important to complete the full course of antibiotic as prescribed? So based on your answer in letter C, why do you think it's important to finish the whole cycle of your medication? Number five, was this activity a good model of antibiotic treatment? Please explain why or why not. And number six, you find out that you have a viral infection instead of a bacterial infection. What would happen to the amount of virus in your body caused by the viral infection each time you took the antibiotic? Okay, so will it have effect on it? Why or why not? And explain. So that's all for the antibiotic resistance project. So you can accomplish this on a paper or on the online document. Just edit the CAMI and submit the edited file to me.